Hello students, good morning. Good morning. Today we are going to discuss one case study. So our case study topic is differential equation. So what is meant by differential equations? So it is nothing but it contains one or more derivatives. Is it right? So we have two types of differential equations. So one is ordinary differential equation, second one is partial differential equations. So what are the stages in DT? F1 is defined, ideate, prototype and base state. Okay? So Anika, start your empathy part.
So I am Ankita and I am here to explain where differential equations are used in empathize part. In empathize part, we generally look into the need for differential equations. So when we divide it into subtopics, we see that in physics, mainly in engineering and technological fields, there is a need of differential equations. Then we have to calculate or predict the motion of a particle, the velocity or acceleration with which object in space, where there is complex dynamic systems involved, including space complexity. In such situations, there is a need of differential equations. Then when we come to the financial sector, we see that in developing growth models of how the financial growth of a country will be, in generally investments and financial and economic related stuff, we need differential equations there also. Then when we come into the biological and medical field, for calculating the birth rate, death rate of a particular country or a certain location, how much the population growth will take place in a particular amount of time, for calculating the life expectancy of many people, like for microbes, and then so many other technological needs is also helped with the help of differential equations.
I am Achutan. I am going to talk about the defined part. In this stage, the real world problem is converted into a clear, solvable mathematical equation using differential calculus. Differential equation. The human-centered problem statement is identify the stakeholders' need. Example: the government need to predict the infected people and need to plan the hospital capacity using the differential equation. For example, the model of SIR is for the SIR model is susceptible population, infected population and recovered population. The total population is based on the people they're infected, and the government should predict the people infected by using the differential equation.
Hi, I'm Amreen. I'm here to say about the ideate part. In the ideate part, our goal is to explore various ideas how our SIR model can be improved. We start by taking a simple basic SIR equation and then brainstorming various possibilities. For example, we take vaccination as a factor and then allowing beta factor to change over time. We also consider whether simple deterministic idea is enough or we need a more realistic idea. In the ideate part, we do not determine whether the idea is correct. We simply generate possibilities so that we can later test it with the model and then choose an idea which is more accurate.
I am Amrita. Next, we are going to see about the application of differential equation. Actually, differential equation is used in physics and engineering, chemistry, in environmental science, economic finance, etc. Especially, its application is used widely in biology and medicine also. For example, when we consider physics, we use differential equation for model motion, heat flow and electricity in RHC circuit. In biology and medicines, it is used to calculate the drug concentration in the body. Likewise, in chemistry, it is used to calculate the rate change of chemical reaction and flow of heat through materials. Then, in economic and finance, it is used to calculate the market trends, interest rates, etc. Likewise, in environmental science, it is used to calculate the pollution rate and pollution change, like growth of equation, and it is used to calculate the climate change also.
I am going to conclude about the topic of differential equation. Differential equations are widely used in physics, science, engineering and many real-world applications. It describes how a quantity changes over a time and period in space. It is also used to describe the velocity, displacement and acceleration in terms of physics. It also describes how current and voltage differs. Also relates the differential equation of current and voltage in the electrical circuits. Models like SI are used to predict how the infection spread or grow or decline. Differential equations are used to predict and understand the behavior of real-world applications. It is also helps scientists to solve the real-world problems by converting the problems into a mathematical expression and finding a solution to this problem. It also helps in medical fields like SIR and also innovate new technologies. It acts as a bridge between mathematics and real-world application. Therefore, becoming a most powerful tool in the real-world industries. We already seen the empathy, define, ideate, and applications of differential equation. Therefore, I conclude my session. Thank you.
Thank you, students. See you next class.